Okay, so let's see. I want to do talk about the scale factor, and you went ahead and looked at that little exploration thing we did on scale factor, where we had the squares and they grew. All right, we talked about perimeter and area. We did a little thing about Polygon Lake, and you went ahead and did the exploration part on that. So we want to just kind of wrap things up, summarize a little bit. You know, we don't have a lot of time here left to do things. We have about 2 weeks, and that's pretty much it. So as far as what we're going to do, this unit we're going to have to cut a little short because we're running out of time, and we need to finish up by doing some little bit of algebra. So we're going to do that next week. And we'll get one more quiz in. I don't think we're going to get a project in like I thought we were going to, but so we're just going to make the best out of it. All right, now let's go ahead here, talk a little bit about the scale factor. So we started out with a square, and then I said, okay, we've got, I'm going to put scale factor here, and then I'm going to put perimeter right here, and I want to lasso this a little bit because I want to move it over. There we go. Okay, and I'll just get rid of that R. All right, put that there, and then put area here. And what I was hoping that you would see out of that, so if I take this square, I'm going to move this over too. Put it right about there. All right, so we got that square, and then the perimeter of that right away is 4 because we have 1, 2, 3, 4 go all the way around, and the area is just simply 1. But if I expand it by 2, so now I'm going 2 in each direction there, the perimeter of that now becomes 1, 2, 3, 4, 5, 6, 7, 8. And the area, by simply counting squares, is 4. Now if I go 3 out, and this is what the GeoGebra document did, now I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and the perimeter is 9. So we can see what's happening is that the perimeter, right, appears to be going up by 4s. So it wouldn't be much to say, does that mean this is all going to be 16? Well, it is, because 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, all the way around. Right, going up by 4s, and the area is also 16 by just counting the number of squares. So the perimeter is definitely going up constantly, but the area is not, because here we have 3, here we have 5, and here we have 7. Okay, it's obviously a pattern, but it's not going up by the same. So what does that mean as far as scale factor goes? Well, it's definitely that the perimeter is going up consistently, just like the scale factor, but that the area is not. So I wanted you then to let's explore something different. So then we went ahead and looked at this Desmos graph, and I think I still have that here. Okay, and here it is. This was the Polygon Lake, where we had the perimeter and we had the area. And I opened up this folder and clicked on that, and I can see by sliding this that 24.6, that is a nice line. So y equals 24.6 gave me a nice consistent line where that perimeter continues to grow by an equal amount. But the area, I see, actually changes more by a curve. All right, so that curve is y equals 11.5 x squared. And sure enough, that follows a curve. But it's an x square. And it's a square because if you think about it, when you have that squares, and we're moving and expanding it up, and we're also expanding it to the left or to the right. So that's why it's a square, because area is expanding in both dimensions, length and width, whereas perimeter is just expanding in one dimension. So it only goes up by ones, whereas a square goes up by two. And that's the idea behind this GeoGebra thing, where I was trying to show you that your area is expanding in both this direction and that direction. All right. So what does that all mean? Well, what it means is when you have a measurement like perimeter, the perimeter of a shape, okay, will change by the scale factor. And that's it. Nothing, just whatever the scale factor is, that's what the perimeter is going to be. So, if we have a shape, right, and it is, I'm going to change colors just for a little contrast here. We have a rectangle, say like this, and then I say, all right, I'm going to take that and I'm going to expand it by a scale factor. All right, scale factor of 2, then that means I'm going to make this thing twice this way and this twice this way. So I'm going to have something that looks like this. All right. So now I've doubled it this way and doubled it this way. But the perimeter, because it's a distance that goes all the way around, is just going to go up by a scale factor of 2. All right. So whatever the perimeter was before, we don't know what it is because I didn't include it, it's going to be double what it was. All right. That's how perimeter works. But area, on the other hand, doesn't work that way. And area will always change, okay, by the square of the scale factor. Square of scale factor. Because when I'm talking about area, all right, I'm talking about this being just one rectangle, but then when I double it along each side, then I get 1, 2, 3, 4 rectangles. So that means it changes by a scale factor of 4, not 2. Okay, it will change by a scale factor of 4. So the area here, area will be 2 squared or 4 times more. And this is a difficult concept for a lot of people to understand. And when they think that something is going to double, a shape is going to double, they think that, oh, the area automatically is going to double. No, the area doesn't automatically double. The area goes up by that doubling squared. Okay, if you're doubling, then it's going to be 4 times. If it's tripling, then that's going to be 9 times. It's going to be squared by that. And if you remember, area is always in square units. So it kind of makes sense that you're squaring it. And again, it comes down to because we're expanding it in both directions. Okay? In both directions. So let's take a look at a couple of different examples of where we would have this. All right, so let's say we have a pizza like this, okay, and the radius is 6. Maybe like the Sunshine or whatever, because they're open now, you can go in and order pizza. Right? So this is a perfect example. But you're going to have some more people there. So maybe invite your friends, or, you're going to social distance, all that stuff. So you're going to double the size of that. All right, so now instead of having 6, this is going to be 12. So you might think, well, that's going to give us, double the amount of pizza. Not necessarily. If we're looking at area, which is what this is, and you're doubling it, that means you're going to take double. That means you're going to take double, which is 2, and you're going to square it. So you're actually getting 4 times more area of pizza. All right, 4 times more, because it goes up by the scale factor squared. Four times more. All right. Let's go with, let's stay with the pizzas here for a second. All right. So what if we have the same one? We got a 6, but then over here they got a 9. All right. So how much more area do I get there? How much more area? Okay, we're just strictly talking about area. Well, we don't know what the scale factor is, right? We'd have to find the scale factor. So let's do that. So if we take 9 and we divide it by 6, remember that's going to tell us what the scale factor is. Scale factor. So I'm going to scoot that down here. So let's find that. So I'm going to take 9 and divide it by 6. Well, really, I can just reduce this, right, down to 3 over 2, which would be 1.5 times. That's a scale factor. So remembering area, though, doesn't go up by just that. You have to take the 1.5 and you have to square it. So that would give you 2.25 times more area. All right. Now, with the pizzas, though, of course, then when we're talking about a thickness, that's a little different. That's a volume deal. But when we're just talking about area, just area, it's going to be whatever that scale factor is squared. Makes for a little interesting problem there. All right. Let's do one more little example. Oops. Let's talk about TVs. All right. So TVs are a good example of this because TVs are sold by the diagonal. All right. So if you have a 30-inch diagonal TV, right, but then you're saying, well, let's get a bigger one, right? Because we're at home and stuff, so we might as well have a nice bigger TV. So let's say we go this way, and we'll go get a 65. Right? 65, so all diagonals, again, are measured along the diagonal. That's all TVs are. So let's find out how much more area we're going to get. How much more area will we get? How much more area? Well, we can do that. But first, before we do it, we got to find the scale factor. Right? Got to find that first. Scale factor. Got to find that first. So scale factor is equal to 65 divided by 30. So whatever that is a scale factor, right? So 65 is bigger. It's going to go on top, so because I want to know how much more. So I'm going to start with a bigger number first. We'll come down here. Let me just get rid of this guy. Give us a new graph here. We're going to go 65 divided by 30. That gives me 2.12. All right, but then remember, that's the scale factor. I have to square that in order to get the answer that I'm looking for because it's area. So it's about 4.7 times more area. So the scale factor here was 2.16 repeating about. Right? And then the actual area, though, that you're going to get was that squared. I'm going to look that back up. 4.69. So you're going to get 4.5 times, just basically a little more than 4.5 times more area. Excuse me. Okay. So that's how scale factor and area and perimeter all work. Okay? It's always on the square. So I'm going to give you some problems to work on with that kind of thing. Review some stuff. Next week, we'll probably start in with some of the algebra, and we'll take a look at that. And then we'll just finish it up. So, again, I would be looking for a little quiz on this particular unit. Even though we didn't finish it, we can still do some things and finish up with some algebra stuff. So, anyway, Monday is another furlough day because we have graduation on Friday. So I'll be back with you on Tuesday. All right, so have a great weekend. Bye.